Okay, Maths Higher Level Paper 2, Question 2. We're just going to go to Calculator page, and we're going to have to do some statistical inverse normal commands first. So if I do Menu, Statistics, go down to Distributions, and do Inverse Normal, we can go for an area of 0.25, and we can get that particular ordinate there. We can repeat the command and do the ordinate for 0.75. So these numbers are going to become important in our later calculations. If we think about standardizing these, 17.1 would standardize to negative 0.67, and so we'd have a statement that would look a little bit like 17.1 subtract off mu would be that particular value of S for sigma. That would be one equation which we'd be trying to solve. When I'm going to press enter, it's going to give me an error here. That's okay. And then the other statement is we're going to be standardizing 21.3 minus m, and that's going to be the positive value of that multiplied by s. Again, we'll get an error. But we have simultaneous equations here. So if I just press menu and choose algebra and choose numerical solve. Nope, that's not what I want to do. My apologies. We'll do menu, algebra, solve system of linear equations. We've got two equations here. I've called my variables m and s for mu and sigma. We'll go down to OK. And what I want to do to paste in that first equation in there to the first gap, and what I want to do is go up there, highlight it, and press Control C to copy it, and then move on down to the gap in the template, and then Control V to paste. So we can get that working. There we go. And when I press enter, it'll execute the values for m and sigma. Now the key thing here is I've done no loss of accuracy. So if I want to keep that going all the way through, I can do m is defined as being equal to, and I can paste this in and then do square brackets. Square brackets is control left bracket or left parentheses, depending whereabouts in the world you are. And if I want the first term for that, then m will be defined as 19.2. And similarly, I can do s is defined as that statement, but I'm going to put in square brackets and for the second element. So we haven't lost any accuracy here. And so when we go ahead and do the second part of the question, we're trying to work out the normal distribution of a value that is more than 22. Again, we could use standardization here if we wish. And so what I'm going to do is I'm going to think of the calculation of 22 minus m all divided by s. That's the value I'm interested in doing. I'm trying to find the value of z that's greater than that. So if I go to menu and go to statistics and go to distributions and the normal CDF from the value which I'm interested in, I'm just going to put 1 and then 9E99. 9E99. I'm just going to leave mu and sigma as they are. And then I'm just going to go back in and edit this and change that lower bound of a 1 to be that 0.99, and I get the decimal I'm after. Another way you could have done that is you could have gone menu, statistics, or distributions, normal CDF, and we're looking from the lower bound of 22 up to the upper bound of 100, but if I just do 9E99, that's normally enough. And for my value for mu, I can choose m. For my value for s, I can choose sigma. For sigma, I can choose s, and I get exactly the same answer that way around, depending on how you've met the topic of standardization. And then simply it's a case of multiplying those values there by 100 and rounding to 3 significant figures. We're done.